electrolytic cell. In an electrolytic cell, electrical energy drives a non-spontaneous chemical reaction and gets converted into chemical energy. Let us see a simple electrolytic cell consisting of 2 copper strips dipped in a solution of copper sulfate. The 2 copper strips act as electrodes. We need a source of electricity, DC power, to drive a non-spontaneous chemical reaction. The positive terminal of the DC power source is connected to the thicker strip and the negative terminal to the thinner strip. When the switch is closed, electrochemical reactions take place at the 2 electrodes. At the positive electrode, copper atoms from the thicker strip lose electrons, that is, get oxidized and go into the solution as ions. At the negative electrode, the copper ions in solution gain electrons, that is, get reduced and get deposited on the copper strip. We know that oxidation happens at the anode, so the positive electrode is the anode. Reduction happens at the cathode, so the negative electrode is the cathode. You might wonder why we would use electricity to drive such a reaction, when the same element, copper, is oxidized and reduced, albeit at 2 different electrodes. If you notice carefully, only the copper ions get deposited on the cathode. Other metals that may be present with copper as impurities either form ions but do not deposit on the cathode, or settle down as sludge. This is due to the voltage that is applied. If the voltage was more, the other ions like Zn2+ and Fe2+ also get deposited. A carefully applied voltage ensures that only pure copper is deposited at the cathode. Note that the sulfate, SO42- ions, do not participate in the reactions and are called spectator ions. Also note that the color of the solution does not change during electrolysis. The electrolyte is not used up. The copper ions deposited at the cathode are compensated by the copper metal that dissolves at the anode to form copper ions. Such an electrolytic cell on an industrial scale is used for purification of copper up to 99.95%. The process of using electricity to drive a non-spontaneous chemical reaction in an electrolyte is called electrolysis. Electrolysis is used to produce many metals, such as sodium, magnesium, and aluminium, as well as gases like chlorine, fluorine, and other chemicals.
Starting to feel it? Now go master it with Maski.